Rainer is Professor for Industrial Information Technology at the Technical University of Berlin. He also served as Director for the Virtual Product Creation Division at the Fraunhofer Institute for Production Systems and Design Technology, IPK. He is member of various scientific organizations. Just to name a few, the German Academy of Technical Science, ACATech, the Scientific Society for Product Development, VGAP, the International Academy for Production Engineering, CIRP. Rainer is also board member of the Prof Association, and he is giving a keynote on artificial intelligence in product creation. Rainer, welcome. The stage is yours.
So thank you very much for the warm introduction of myself. I hope you can see everything. Welcome, good afternoon from my side. Yes, we have a couple of great opportunities, but also some roadblocks if it comes to artificial intelligence in product creation. I would like to take you through that kind of keynote today. I will have three areas. I will start with the importance of AI for engineering, and I will go through a couple of engineering cases to understand or provide an understanding what are the options and what are also the challenges there, and I will close with summary and conclusions. Now with that, let us start first of all to understand a little bit better what kind of AI we are talking about, and we recognize kind of three waves of artificial intelligence. The first one was the more handcrafted knowledge based on a lot of rule-based elements and with a lot of knowledge capturing. And here you see how much that is in terms of the perceiving, learning, abstraction, and conclusion kind of target. It was mainly conclusion. That was the first wave, started in the 50s from research perspective. Statistical learning became quite important from the 90s onwards in the research area, where we had statistic models and first AI systems based on that one was trying to imitate a certain intelligence. Compute power was more and more increasing, and perceiving and learning was more in the forefront of that. And obviously we have other areas like explainability and contextual adaptation, where we are now looking from research perspective on it. And that is maybe something which becomes more important in the future. Interestingly enough, if you look to the first industrial impact, although it was started in the 50s, the first wave hit the industry mainly in the beginning or in the 90s, whereas the second wave, the statistical learning, started in 2010s, and we are in the middle of it to make it industrial-wide applicable. And we see now, because of autonomous systems and so on, that we have to look more for when can we have explainable and really gray box kind of approaches for something in 2030 and beyond. Now, with that understanding, obviously, we have a certain dilemma to overcome, which is in vertical silos, sometimes a difficulty, because we need to have the right data to use it. And if you see this kind of circle, like identify required data, collect them, and then really apply AI techniques to basically evaluate it and to train it and bring it to the forefront to the areas where we need it and want to apply it. We do have the challenge that we need to have the right data available, and we need to become serious about them. And therefore, we need domain knowledge. Domain knowledge in community, that is where the experts are, whether it's in product creation, the development processes, or production systems and factory environment. And we need it also from the get-go when we want to identify the right data, but also if we want to make effective use of the right systems here. Now, specific AI knowledge is required, like data analysis, data scientist elements. And you see that here in the right area, we need to have the right data pre-processing, feature engineering allocated to that one. And we need to have other areas like the pipelines we need to entertain. Now, with that, obviously, there are examples which you already have seen of where we can see certain elements of AI, and whether it's in component design or whether it's more in integration aspects, we're still hitting many problems because we have organized our data in silos and we need to make them available before we can process them. That's the challenge. If you look from the other perspective to it, from the engineering side, we recognize that we no longer can entertain just manual development processes in engineering. We want to go to more feedback loop areas, assisted or maybe even autonomous or automated engineering processes. So the question there is, first of all, independent, but also in combination with AI, how do we want to assist engineers in their respective activities? Do we have low-level assistance? The computer offers no assistance. It's all need to be done, also method-wise. Or can we even go to the very high assistance that the computer is preparing decisions and we just reflect them? So that is a big discussion within product creation, which engineering tasks are good for which type of a system, where AI will become an indispensable aid, because we cannot foresee and entertain all the data just by human thinking. So we do have a need to use AI in any case. So let me come to 4 or 5 engineering cases, and I on purpose don't call them use cases. This is misleading because every engineering case has multiple use cases going with it of how you really interact with it. So the first one we have worked on is, can we use AI to really help engineers and project managers to automate the project progress measurement? And this is a tedious and painful activity in many projects in industry. There's a motivation that we want to get a more get rid of the selective manual progress measurement, as it is tedious right now, because that results in a selective management mode of how you really have human beings in the room to do that. Or can we go into a more neutral automated assessment of the progress of product development activities based on something AI can support us in measurement? How far are we with the digital artifacts? How far are we with our collaboration, so that we can gain those benefits to have more continuous automated kind of activities, and that we can enable continuous managing mode of the project and not just to milestones, which is sometimes to cause. Second engineering case is the modeling itself, like in a CAD assistant. So that what is the next best modeling action? We all know from introducing more and more refined parametric approaches and then knowledge-based approaches, but now we want to see how can we help engineers in using those modeling tools to really make the right modeling steps, although maybe not the training is always that deeply already fulfilled, but the system supports it and makes it easier, or even for casual users. By learning from the historical CAD command sequences, depending on the modeling approach in the various CAD systems, this is or becomes possible. And partly automated design can be suggested, at least, if not conducted. But we have challenges of the implementation, because you know how it is with AI, with the recall and precision. And if you have a good process like 70 to 75%, what are we doing with the rest uncertainty? And there needs to be an engineer, like in this the door design example, who needs to have the final saying about how exactly the feature modeling is being done, or what kind of modeling steps are there. But there are great potential, as the activities from Mercedes already shows. The third engineering case is AI-supported collision management. We do know that we entertain, especially for bigger systems, a lot of digital mock-up interfaces and investigations, but there we still have, although we use digital mock-up already for 20 years, the challenge that we have recognized and detect a lot of collisions which are actually not real condition, but they are based because of the modeling approach we are using, and we can select them out. But to select them out, the existing solutions are not good, and a lot of zone engineers and DMU engineers have really challenges with it. And we really put too much burden on the whole engineering team just going again through a collision which is already under control. So machine learning to classify collision is a relevant activity which can distinguish between what is a relevant or a not relevant collision. And this increased speed and quality of collision management, which can increase substantially the engineering progression. And therefore implementing AI, because we have actually a lot of data available within the respective companies in their DMU process, but it needs to be prepared in such a case. Now, something which is quite tedious for those of you who have been in that challenge and in that responsibility is engineering change management. We know lead times and how costly changes can be. We could learn a lot from existing data if we have the right access to them. and machine learning to apply not just on the requirements and functionalists, but also in the components. And also from the incident reports we had in the past, there is a motivation to really get from the starting point to solve the unexpected propagation of aging changes, to use it with more pre-knowledge based on the data we have from history, and that we can avoid of spreading unnecessary challenges and changes to the other products or components in the product. So the solution is how can we find pattern in historical data using NLP, natural language processing, which is one element of AI, algorithmic or methodological approach, and how can we predict affected components in the early phase of the aging change management process. Yes, obviously from the research we are doing with industry, there are a lot of data quality and text data change requests which are not nicely filled out, and you have interpretation challenges. But if we can overcome that and we can learn over time, we have already evidence that there are early detection of change impacts possible, which really streamlines the ECM process, and it's earlier and better planning possibilities we have to do that. Let's come to the fifth engineering case. This is AI to support production planning. So there the idea is that we really get rid of the old-fashioned process planning as we still do in many companies, and give new support tools where we basically train an agent with discrete event simulation as we can leverage them, but many companies don't do that because it's too cumbersome, it takes too long. But if we have an agent where we now have an AI supported agent which really can assist in real time the manufacturing system and process planning, then the process planners really get a new support aid, and that is really something which we need for quicker changes we have to do in the future. So motivation is to overcome the complexity and in process planning and in the product by solution and applied reinforcement learning to find best possible planning and scheduling actions. And therefore, we really deliver as benefit increased efficiency of planning system with that one cost reduction. And we have more time to go into the sustainability reflection, which we in many cases don't do yet due to time challenges. Now we have implementation challenges there. It's the accuracy of simulation, the quality of real-time data. That is something which need to be overcome. So let me summarize and conclude for my impulse here to the AI Marketplace event today. So AI might become a game changer in product creation if we can really tweak and change our engineering operating system to make the right provisions for it. And we need to do that together with senior management, because to change conventional operating processes in engineering is not that simple, as most of you know. The second, AI needs to earn trust. And this is something real serious. And the best way to do that is to use useful and reliable engineering assistant. That is why AI Marketplace looks exactly for those scenarios. So that we can convince engineers in different activities as they are outlined here. The third area is the perspective from isolated AI engineering case towards AI-based product creation processes overall. If we can combine that, that's an interesting and striking idea. However, to be quite honest, at this point in time, we are still a little bit far away from it, because it really takes a lot of efforts right now to build, train, and run AI solution in product creation. But we will overcome that over the next couple of years. So the sooner we know the combination, the better it will be. Fourth point, product creation engineers need to combine their domain knowledge with new data engineering skills. And that is the big challenges. And data engineering becomes a new discipline, because it's not only data acquisition and collection, but also the preparation and the labeling and the changes and the analytics elements. Not too many engineers have good statistical knowledge, and we need to now have new forms for data visualization to really use it in collaboration. Now, data scientists, that's always a big question these days. They are necessary if they can assist in deep dive algorithmic knowledge, where engineers usually cannot have all this knowledge, but they are not at the forefront to make that happen at the application side. Now, we observe an interesting situation that industrial leaders recognize that AI needs to be integrated into so-called business analytics competence centers. I know a couple of companies who are doing that. However, we did not see industrial leaders really stepping up to commit to establish data-driven AI as a core new engineering discipline, but this forum will be a cornerstone to make that happen. And the last conclusion, the new engineering intelligence we have to look for because of our, let's say, new compelling networked systems. We need AI. Without AI, but we need to be able to control and make it explainable, as I indicated on the first slide. Without that one, we cannot progress any further. So with that, I would like to thank you for your attention, and I'm ready to give any kind of answers and questions. Thank you.